Greetings to all of the Electrical Protection 3 students from Walter Sisulu University. I am Cikizwa James and I will be your lecturer for this module. Electrical protection really is looking at ensuring that your power system is always operating within its specifications and that it is operating in a safe manner that does not endanger the equipment or the people that are working with that equipment. So the first module that we're going to be doing is called the fundamental principles. And what this module is going to be doing for us is going to be showing us what type of faults we can expect from the systems and what type of protections we should employ in order to make sure that we isolate those faults. In electrical protection, we don't talk about not having a fault, but we talk about if a fault is occurring, what can we do to ensure that we try to save your power system as a whole from a lot of damage, and we need to do that saving as soon as possible when that fault actually occurs. So I've switched off the video so that you can concentrate onto the slides and not be looking at me while I'm talking. I just wanted you guys to see the face. Now, power system components is what we need to protect within our electrical power systems. And those components, as you would have learned now from machines, we talk of generators, we talk of power transformers, we talk of motors, we talk of transmission lines, distribution lines, cables that are underground, and we talk of bus bars that you will find onto your substations and power stations, and then the switch gear that goes with it. So these all constitutes what we call our power system components. And the role of protection within those power systems is to ensure that we remove any element of that power system in which a fault has developed, and that needs to be removed as speedily as possible. If you can remove it in a very fast manner, then it means that you have got protection into your system. But when we delay to remove a faulty component from the power system, then it means that our protection is in fact not effective. We define a fault in two ways when we're talking about our electrical power systems. The first way is when there is an event that actually occurs on the actual equipment or the power system itself, and that event causes an automatic tripping of the circuit breaker. Now, usually that event would be something that is against the specifications of how the components are supposed to be operating under. So you could be over temperature or you could be overloading. Any of those would then trigger saying that the breaker must operate because that component is no longer operating at what it is designed to operate at. The second one is that if you have operation in error of a circuit breaker or an isolator done by the operator that is in the field, or it can be done by the person that is sitting in what we call a control room. Those people, if they press a button and it opens up a breaker or an isolator, then we also say that becomes a fault. Although it was not a component that was faulty, but it was an error that was done which made the system no longer available to your electrical power system. As our electrical networks are usually three-phase systems that we deal with, we're going to be looking into two types of faults that can happen in those systems. The first one is what we call a symmetrical fault. And this means that all three phases, either they have an earth or not, but you will have a fault on all three of your phases in your system. Whereas sometimes you could have an unsymmetrical fault where you only have a single phase to earth that becomes your fault, or you have two phases, a flashover that can happen between your red and your white, or your white and your blue, then we call that a phase-to-phase fault. And you can also have what we call a double phase, which is that phase-to-phase and then to earth fault. In other words, it doesn't become a fault that is on all three of your phases, but it can only be a fault that is on two phases on only on one of your phases. So that becomes unsymmetrical because it's not a fault that is happening onto your entire three-phase system. So these really now show us the diagram of what we talk about when we say symmetrical fault, and you can see that it is happening between all three of your phases. Whereas in your unsymmetrical fault, you can see that in the first diagram, you have only the single phase to ground, or you have in the middle one what we call a phase to phase, and this one shows that it's between your white and your blue. It could also be between your red or blue, or between your red and your white. And then on the last one, you can see that it's between two phases plus earth. So those are all our unsymmetrical faults. So when we speak about the nature of a fault, we are talking about the behavior of that element of the fault. And in this case, we say that the nature of a fault is defined as any abnormal condition which will cause a reduction in your basic insulation strength between your phase conductors and earth, or any earth screens. So in other words, your insulation is what is protecting your eddy currents or your fault currents to escape from one phase to the other phase, or to escape from a phase to earth. And if our insulation is compromised, then usually it means that your insulation actually breaks down, and therefore allowing those currents to escape from the one phase to the other, or from a phase to ground. And we say that that reduction of your basic insulation is not regarded as a fault. Not until such an event that your currents actually do escape from one phase to the other, or to earth. Then we say there is a flashover, which can clearly be defined as a detectable fault that has occurred onto that system. So for transmission lines, we say that only 10% of the faults that actually occur there are permanent faults. Every other fault that occurs is called a transient, which means it's a fault that doesn't last long. It is there for a short period of time, and then afterwards your system is back to working into its normal operation again. So your permanent type of faults are caused by lightning. When your lightning strikes onto your conductors, it is breaking down your conductor strength, and it can bounce. They're not usually built up in these nice fancy places that your distribution lines get built in. And due to this, we always then recommend that bush clearing is something that needs to be done at least once a year, to make sure that we protect those transmission lines. Then we've got intaka, birds, your large ones. And as kuhle sometimes, because they're also wanting to scratch, and they nest there such that on top you can have a place where a bird can be able to go and stand on. I can't say a bird actually sits, where it can stand on, where it can build a nest, so that it moves away from the insulators. It doesn't do that on the actual insulators. Then your other type of permanent faults can be a broken insulator, the structure. Then you've got your lightning arresters to attract the lightning to there, it would then mean that you also have that scenario in that case. So our conductors, and if you have overloading that occurs there. So when we talk about your underground cable, which we usually find at distribution level, we will have mechanical damage, we will have joint failures, and we will have solid insulation failures. So your mechanical being caused by your breakdown insulation, either due to bad handling when we're putting in the cables, or it could be because people are digging next to roads or whatever the case is, and it causes a mechanical damage on this cable. Your joint failure is mostly caused due to people not doing the joints in the cables properly initially. And as the cable then is operating, you find ukuthi that joint becomes loose, and therefore you end up having a joint failure. Or sometimes because of the faults that are occurring into your system, they reduce the strength of that joint. Then for your insulation failure that is solid, it's caused by the moisture ingress that happens underground, because remember, underground you've got lots of water that is in there. So once your cable is in this water and then it gets in contact with earth, you have faults that will occur. And all of these faults, they can be reduced, not necessarily totally prevented. So your mechanical damage, you can make sure that you do insulation breakdown tests on a regular basis. Your joint failures, first of all, when they're installing the joint initially, we need to make sure that that joint was done properly, and there are tests that can be done to make sure that you've got continuity into your cable when you first put in that joint. And then again, if we do the basic insulation every now and again, it should reduce our joint failures. And then for your water ingress or your moisture that you have in there, it would assist if we make sure we put our cables in ducts. And in most cases, we run away from that because it becomes expensive putting all of those pipes underground in order for you to pull the cables in. For cables, we say that we should not have an arc. And what is an arc? An arc is an auto reclosing system. And what an arc does, you put it on your overhead lines, which is your transmission that we discussed, or even on your distribution lines, because the causes of faults are similar for the two. And an arc you put in there so that for the 90% of faults which are not permanent, all right, those ones that are for a short duration, we can make sure that we don't isolate that system permanently. So an arc, it will automatically close after a certain period of time that we set it to close at. And if nothing happens when it closes, in other words, that fault is no longer there in the system, then it remains closed. But if that fault is of a permanent nature and it is still there in the system, then it will open again automatically. Whereas in underground cables, we say there is very little chance of you having a transient fault. Your faults that you get in underground cables, it means that there is an actual fault, and it could be either from mechanical damage or for your joints, or because of water ingress. Therefore, you should not have an auto reclosing scenario in there, as you will damage the cable further. Then for transformers, we have got insulation that deteriorates over time, caused by high operating temperatures that we induce it to. You've got mechanical damage that can happen on your actual insulators. You've got ingress of moisture and contamination of the transformer oil. And you've got over voltages that happen on your system as surges, and you've got abnormal transformer loadings that sometimes we cause as the people that are supposed to be looking after these transformers. Because we don't have enough transformers in the system, we overload them. Then you've got faults reduced. All of these faults can be reduced by doing your preventative maintenance. And for transformers, it's usually very easy. We do inspections, okay? Sometimes it's a visual inspections because your ingress, or if your oil is contaminated, you can see it. There is a signal on the transformer that is a glass for you to be able to see that. Your insulation, you can't really say if it's deteriorated, so you do a regular insulation resistance test on your windings, and they will tell you how good that transformer is. Then on your generators, you and your motors, I'm combining them because they are similar in nature. One generates, one pulls. So your insulation deterioration causes by your high operating temperatures, by mechanical damage to the insulation, and we say that the arc on generator and motor protection systems is also not installed because it damages the equipment, which is going to be expensive to replace for you. So if there's a fault in a generator or in a motor, irregardless of it would have been permanent or not, we say go out, go and test before you put it back in service. That's why we don't want it to automatically reclose. So what protection schemes then do we employ on our transmission lines, which will also be similar to the distribution lines for most cases? So we've got distance protection, and we have overcurrent and overload protection. We have got earth fault protection, and we have what we call your auto reclosing feature, which discriminates between your permanent and your transient faults. Then we know that for some distribution feeders, which is now your distribution lines, we do not install the arc because it could become fatal to human beings and the animals. So where our lines in distribution are going over areas that your transmission lines would have been going over that are not really built up and people are not really staying there, you could have arc protection in. But where it's going to your townships, to your lallies, then you want to remove that arc because it could actually close on a fault and someone could got hurt at that instant that it has actually closed at. Then your distribution lines, what we put instead of your arc is what we call the sensitive earth fault protection, SEF in short. And this we install where conductors frequently fall to the ground, and the overload protection system is unable to detect that due to the high resistance that the earth soil will have. So they install that in there so that once a conductor is down, is on the ground, then that line can be switched off, and if you step over it, or a child or an animal, it does not get hurt or killed. For your transformers, we usually have what you call the Buchholz protection, where we have a relay in the transformer that will protect the transformer against internal faults. Then we have differential protection, where we look at your current coming in versus your current coming out is the same, obviously taking into account your transformation. Then we have what we call your overcurrent, where there is a system error or an overload protection, where we have gone beyond what our loading should be on the transformer. And then we have also got an earth fault protection onto the transformers. And then our distribution cables, we will have overcurrent or overload protection and earth fault protection. Generators, almost similar to the transformers with differential protection, overcurrent and overload protection, as well as earth fault protection. And then on motors, we have thermal overload protection, and then our overcurrent and our differential protection. And that, ladies and gentlemen, is the first lesson of the very first module on protection 3. I hope you have gained something. And should you have any queries, please WhatsApp me, call me, email me. I am available to explain anything that you do not understand. Thank you.